Hi guys, today we're going to be looking at word problems and system of equations. So in this first problem we have is you have 20% acid and 50% acid. How many ounces of each solution should be mixed in order to have 60 ounces of 30% acid solution? So we're going to go ahead and set up a variable. So we're going to say A is going to be the 20% of the solution, and then we'll say B is 50% of the solution. Now we're going to have to come up with an equation for that. So our first equation that we're going to write is going to be A plus B is equal to 60. Now how did we get that? We know that you need 60 ounces. So because A you don't know and B you don't know, you just know that they have to add up to give you 60. And then the second equation we're going to come up with is going to be, how do we get percent? How can we get 30% of a solution of acid? So we set it up like this, percent. 20% can be written as 0.2. So 20% of whatever amount I have of A, and then 50%, because the other one has 50% of whatever I have of B. If I add those two, I can get the percent combined together of how much acid they have. So those added together is going to equal, and now we want 30%. Now, while you're multiplying is you're saying, okay, this is how many ounces I have. 20% of this and 50% of these ounces. Added together is how many total ounces you have. And you want that to be equal to 30% of the total number of ounces. So this is going to be 30%, 0.3 of 60 ounces, because that's the total you have. So it's going to be 0.3 times 60. So I go ahead and I set up my equation. I have A plus B equals 60, and then 0.2A plus 0.5B is equal to 0.3 times 60. Now I'm going to isolate the variable, which means I have to solve for either A or solve for B. So this is what that would look like. Here I have isolated, so I have A plus B equals 60. Let's see if I can zoom in for you. So I have that. Okay, so we isolate the variable, so that means let's get B completely by itself or A completely by itself. We subtract A from both sides, so that looks at like B equals 60 minus A, and now I can use substitution to plug it in. So I use my second equation, I plug it in for B. And so I get, I did the same thing, I solved for B, so I got B equals 36 minus 0.4A. And actually they didn't even do that. They're going to use their graphing calculator. So they're setting this up as X and Y. So they're actually going to graph this 60 minus A and then 36 minus 0.4A. So they just subtracted 0.2A from both sides, then divided by 0.5 and got B. And they did that so that you could enter that into your graphing calculator and find the intersection. So it says here, find the point of intersection. You will have to adjust your window to see the intersection. So you're going to do this in your graphing calculator. If you enter this, then you can come up with where, how much, where did they intersect. So they end up intersecting at 40, 20. So 40 ounces of solution A, 20 ounces of solution B. And so find the values, we just write that in words. A is 40, B is 20, write it in a sentence. So to make 60 ounces of 30%, we are going to use 40 ounces of A, and we're going to use 20 ounces of B. In the second example, we're going to find breaking even. We've already done problems like this. So here we have, in the business, the break-even point is where the costs equal the expenses, so you're making zero money. A metal furniture invests $30,000, and each share costs $10 to produce and sells for $70. So we're going to say that N is the number of chairs and M is the amount of money that you're making. So let's go ahead and take a look for cost. For cost, it is costing you $10. So it's $10 per chair. So really, it would be 10 times N, the number of chairs. Also, you had to invest some money at the beginning, which is the $30,000. So this is my cost. Now I'm going to figure out how much money am I actually making. So the income. So my income is going to be, I'm making $70 per chair. So my income is going to be $70 times N, because that's the number of chairs. So now I have my two equations. I want to know when they equal each other. So they're going to isolate the variable. They are already isolated. We already have both for M. So So technically that's done. Now I need to graph this on my calculator or solve it somehow. So I go ahead and enter this in my calculator, enter this into my calculator, find the point of intersection, and it tells me that the calculator is intersecting at 3,500. So they want us to now write that in words. What are we talking about here? So find the values. We're saying that 500 is going to be the number of I think it was chairs, and the other one is going to be the number of chairs and the amount of money. So 3,500 chairs, and that's going to give us $500. So to break even, again, let's just be sure that those are my variables. M was the amount of money in income or expenses, and N is the number of chairs. So if I make 3,500, if I make 500 chairs, I will make $3,500, which means that I will break even barely enough to make zero amount of money. Okay guys, so let's go ahead and do example 3. In example 3, it says that you have a plane or boat and it's going against the wind or water, and so the speed is going to decrease. So it says an airplane is flying into a headwind traveling at 2,000 miles and then on the return flight, the same distance is traveled in 4 hours. So to Chicopee, it takes 4 hours and 30 minutes. Back, it takes 4 hours. So since it was going against a headwind, it was slowing it down. So they want us to define the variables. So A is going to be the speed of the airplane. B is going to be the speed of the wind. So we're going to go ahead and write our equations. Now, since the wind is making it become slower, that's actually going to affect our equations. So let's see. So we're going to go ahead and be adding A, which is the speed of the airplane, plus the speed of the wind, and we're multiplying it by 4 because that's how much we want to know distance. So distance is 2,000. So we would say the speed of the wind plus the speed of the plane plus the speed of the wind, that's the total speed, times the 4 hours that's on the return flight. So I'm going to just kind of draw this for you, see if you can understand what's going on. Here's my airplane. Okay, sorry, I know it doesn't look like an airplane. When it's going to, it's traveling against the wind, so we're not going to be adding here. When it's going back, the airplane is going, the wind is helping it go faster, so we're actually adding the two speeds together to get the total speed. So if I add A plus B, I get the total speed. I multiply by 4, which is the number of hours it took to get back, and that gives me the total distance, which is 2,000. Now we're going to apply the same kind of reasoning, but when it's going to Chicopee, it's traveling against the wind. So we're actually going to be subtracting the speed of the airplane minus the speed of the wind, because it's going to be slowing it down by that much. So let's go ahead and take a look. Whoops, sorry. Let's take a look. In the second equation, we would be writing the following, which is A minus B times the time it took, which is 4.5 hours, equals the total distance, which is 2,000. So we're going to go ahead and solve for one of the variables. Now, before we do that, we do have to make sure and simplify this. So what they ended up doing is dividing everything by 4. That's where they're getting this 500 from. And then same thing for the other one. They divided everything by 4.5 instead of distributing, and so they got A minus B is 444.4. From here, it's just solving, guys. I subtract A from both sides, so B is equal to 500 minus A. Same thing here. I subtract A, divide by a negative, so I'm left with B. So I know that B is equal to negative 444.4 plus A, and it's also equal to 500 minus A. So to find the point of intersection, I can graph. I could put it in my calculator, hit enter, find where they intersect. So if I do that, then now I know that they're going to intersect at, the point of intersection is actually at 472.2 and 27.8. So we need to find, what do these values mean? We're talking about 472.2 because that was A, and this is B, based on this equation, this is x and this is y, so that's why I set it up like that. So that's the speed of the airplane. This is the speed of the wind. So the wind was traveling at 27.8 miles per hour. And so now it says write it in a sentence. So what did we notice? Well, the airplane is traveling at a speed of 472.2 miles per hour, and the wind is traveling at 27.8 miles per hour. And that is it for this section, you guys.